going to start with this problem. What I would do is we're on the flip side. They've given us the graph, right? And we're trying to come up with that rule of how did you get that graph. Does everybody understand what we're trying to accomplish? Because I think having goals in math is always important. Does everybody know what the problem is asking us to do? Okay. So obviously, if you think back to these problems up here, if you think back to this problem back here, you see how this thing looks, where it's got a rule and it also has a domain for the rule, meaning you only use this equation when x is less than 4. If x is bigger than 4, then you use this rule. Okay? So if I go back down here and I think about, okay, what are the things I need? Well, I'm going to need a rule, and I'm also going to need a domain for that rule. Does everybody understand? Okay. So look right here. First thing I look at is the picture, and I say, do you see how it looks like the graph changes right there? And it looks like the graph changes right there. So how many rules and how many domains am I going to have to come up with? Changes here, 1. That's all one graph. 2, changes there. 3. So I've got 1, 2, 3. And we can do this. Let's do it in colors so we can help. 2, 3. Is everybody okay with that? Well, let's come up with the domains first. Let's see where the rules are good for. So, for the first one, the red. Where does that domain good for? I don't want the rule yet. That's going to be, I'll think about that. I want to know what x's does this one go for? X is less than -2. Now I have a choice here. Do you see how this picks up this green and the red intersect? Do you see how the green and the red touch right at that point?
Yeah.
Thank you. I'm thinking about something else. X is less than -2. What? Do you see this 2 right here that I'm referring to that my brain was on? I can either stick it with the red or I can stick it with the green. And it doesn't matter because both of them use that same point. But I can only stick it with one of them. So I'll let you choose. Do you want this one to be the equal to 1? Or do you want the green one to be the equal to 1? And for this one, it wouldn't matter which one you picked. Do you understand why? So I'm going to leave it like that. Green. Where does green start at? -2 is, not a comma. -2 is less than x. Or what? Less than or what? Equal to. Remember I told you have to put that equal to on one of them. We chose this one to put it on. Which is x is less than or what? Equal to 2. Now since we chose to put the equal to there, my next one, am I going to be including the 2 in the next one? So I'm going to say x is what? Greater than 2. Does everybody see how I can see this one? The red gets cut off right there, which is x being -2. The green starts here and ends here, and the blue starts, no. The blue starts right here and goes on to infinity. Remember, when I'm talking about domain, am I referring to how high or how low it gets? No, I'm only talking about how far left and how far right it goes. Does that make sense? Okay, so those are the x's that these are going to work for. So let's go back to the red. How would I describe that? First off, Matt said if you look at this guy right here, it's linear because it makes a straight line. Well, what kind of line is that? A horizontal line. When it's a horizontal line, do you notice what never changes? What stays the same every time I change my point?
The y.
And y is always what? So guess what this equation is? Y equals -8. So how would I write that up here? What does this represent? What does this represent?
Y.
So all I have to put here, do you see how I put this like bracket? Because y equals 8 when x is less than -2. So as long as my x is less than -2, I get a -8. Sorry, I should put -8. You with me? I'm going to go skip to the blue section, just because it's easy, the next easiest. Should be very similar to what we just did, huh? What happens with this one? What kind of equation is this? So y equals, because it's a horizontal line, and this is going to be y equals, what does y equal? 8. When x is greater than 2. Do you see that that's what that is saying? Now, this middle part. What kind of graph? First off, just tell me some of the stuff that we know.
It's odd.
It's odd. It's probably cubic, because we've seen cubic graphs like this. Is my turning point? It's positive because it starts down, ends up. Very good. Awesome. Is my turning point, has it moved from the origin? So has it shifted right? Has it shifted left? Up or down? So it's just x to the third power. And how can I check that? If I put some points in there, right? If I put in 1, what's 1 to the third power? Is that the output that I got for here? Okay, try 2. What's 2 to the third power? Is that what I get out when I put 2 in? Yes. Do you see how I can check and make sure that my equation is actually getting the ordered pairs that they're asking me for? Good? All right, next one. This guy. How many different graphs do we have? Because that's one thing I like to decide first. How many different graphs does this guy have? It's only got 2. Put my little brackets. It's got this part right here. And notice what happened right there. What happens at this point right there? So it doesn't include x being 1. Remember, it's what the x is. X is allowed to be everything all the way up to 1, but as soon as it comes to 1, it kicks to the blue graph. You guys with me? All right, so where does the red graph, what does x have to be in order to use it? X has to be less than 1. It's allowed to be equal to for that graph. No. What do I know about my blue graph? X has to be what? Greater than or equal to 1. Does everybody understand that part so far? Now, how do I figure out the equation? Well, what are these guys right here? Okay? This whole chapter, I've been giving you a nasty equation in standard form. What have you been doing to it? Because I've been asking you to give me the equation, and I'm asking you to graph it, right? So I ask you to take this, double bubble, factor it, or whatever you have to do, and then you can graph it, right? Find the x-intercepts. Well, this time, I'm giving you the graph. So from the graph, what kind of equation can you create really easy? A factored equation. You're just moving it backwards, right? You're using the x-intercepts to put the factors down. And then I'm even going to allow you to leave it in factored form. But on the EOC, if it's in standard form, what would you have to do with all these bubbles to turn it back to standard form? You'd have to distribute all this stuff, combine like terms. Then you'd have a bigger bubble times a smaller one. Distribute again, uncombine like terms, and you finally end up with the final equation. Yes? We're going to include that because we're going to include that as our 0. That's where it's approaching. However, we cut that part off. So remember, this graph continues on. But what did we do? We said we're doing it piecewise. I'm cutting that section off. But that would still be part of the graph. Or the equation that got me there. Does that make sense? This. The blue's a totally different equation. We're not worried about him yet. We're doing blue later. Okay? So let's talk about this. What are the roots that I can find from here? X what? What's the root? Well, no. Hold on. What's the root? Negative 3 is my root. What is my factor based on that? X plus, is it 3?
Oh, 3. Sorry.
You're okay. Does everybody understand that? What's my root for my second one? Negative 1. What's my factor then going to be? And finally, what's my root? 1. What's my factor? X minus 1. Does everybody understand? That would be my equation that would get me this graph right here. And this equation holds true. This equation holds true when x is less than 1, but not equal to. That's why they put that open circle there. How we doing? Amazing how it all comes back together, right? I'm not teaching much, anything new really. We're just going backwards. Okay, what about blue? What kind of graph does it look like it's going to be? Looks like half of a parabola to me, correct? So, what form do I like? Especially since I'm just going to assume we're not going to be nasty to you guys. This book is pretty nasty. But I'm going to assume that they're going to be nice to me. What point do you think that this is probably going to be? The vertex, right? The vertex, because then I can put it in what form? Vertex form. Because quadratic formulas have a vertex form. Are you with me? What's the vertex? 1, 5. If I'm going to put that in vertex form, I can start by doing this. X, what? Minus 1. What else on the outside of that bubble? Before that. Squared. Don't forget that little square, because that's what makes it quadratic. Plus 5. Now, am I finished? What do I know about this parabola? It's facing what? So what do I know about out here? Now, remember how I said check some points? Remember in my normal parabola, I would be here, and if that was my vertex, I'd go over 1 and up 1, right? Well, look at this guy. I go over 1, down 1, 2, 3. What does that mean I have? Not a slope. Starts with an S, though. Stretch. I have a stretch, and my stretch goes right here, and my stretch is 3. Do you remember that? Looking back at the book, this is not, they wanted this to be the vertex. I would not give you a problem like this. I think that that's a little bit ridiculous to sit there and take that much time to figure out if it's a vertex, to try to come up with the equation. So this is actually not the right equation, but if this is the vertex, which I'm telling you, if I was giving you one of these, it would be like that. Does everybody understand what I'm saying? Then that's the way that I'd want you to do this problem. They're saying the vertex is this, so their actual answer is x cubed, or x squared plus 6. I don't really like that. If I was giving you a problem, like I said, I would give you the start of the vertex, because I'm not going to ask you guys to have just a piece of the problem. Does that make sense? All right. Negative. All right, so 5-5. We're going to skip all the way to 5-5. All right, so 5-5 is a great section because it is some thinking stuff. It is going to, it's like brain teasers with all the stuff that we have done since the beginning. All right? So I'm going to try to give you some time, and I want to make sure I don't mess up. So basically everything we've done. Brain teasers with all this. Because we're going to talk about, so we're going to be comparing two different forms of functions. And based on that, we're going to ask, like, what, so these are good questions to ask for these. What information is given? What's the degree? What do I know about all functions of that degree? What are key characteristics? So, like, this problem right here is an excellent example of what I mean by a brain teaser. First off, let's look at this guy right here. How many turns does it have? It has 3 turns. What do I know x has to be at least to the power of? 4. Because, if you remember, it has to have 1 minus the power that it is, right? And it goes down by 2. So this could this be x to the 6th power technically still? Yes, it could. Remember that? Okay? But we know that at least has to be x to the 4th. That's the smallest that this graph could be. Now, what else do I know? They're asking me, so that's the first thing. I've figured that out, but I guess I should ask what the question is first. Which polynomial has the greater number of real zeros? Remember, because these things can not only have real zeros, they can also have what? Imaginary. But imaginary, one thing I need to remember is they have to come in what? Pairs. So keep that in mind. You guys with me? See what I was talking about? How it's got all the stuff that we've done. So here we go. It's a good review. I know that this thing has 3 turns, so it has to be at least x to the 4th. But that means it should have 4 times that it touches the x-axis. When I look at the picture, how many times is it touching the x-axis? But, when it's touching, what is happening? It's going back up. What do I know about each one of these roots? So this is probably x to the 4th power would probably be a good thing to describe this by. Does that make sense? So how many real zeros does this have? It has 4 real zeros. I know it doesn't have, I know that it has at least 4 real zeros because I know these both have multiplicity of 2's. How many real zeros does this have? What is this? This is x to the power of 3. So how many real zeros, how many zeros does it have? It should have 3 zeros, combination of real and imaginary, right? Well, it can either have 1 real and 2 imaginary, and that's really it, right? Or all 3 have to be real. Well, what does this tell me since that root has a 3 on it? It has 1 real root, but with a multiplicity of 3. So how many real roots does this count for? How many real roots does this count for? 3. This has 3 real roots. How many real roots does this have? So which one is the greater? G of x. That's an excellent type of question that they're going to be asking you.
Do you make your tests, or do you get them off of a program?
I pick problems from a program, so I make them via a program.
I was wondering why you say that it would be for your tests.
Yeah, because I pick them. Plus, I don't want to prepare you for my test. I don't want to prepare you only for the EOC. I want to prepare you for any type of question that you come along, any type of math teacher you're going to ever have in college or whatever has to happen. I always try to teach that. I don't ever teach to just one single thing. So I try to do the best I can to prepare you for anything that comes along. All right, so here we go. So another type of question, Toby. This one is dirty. I actually got it a little bit. I didn't pay attention because I'm thinking that the book is going to be a little bit easy on you, so it's going to be nice, and it's not. So you have to think through every one of these questions. So Toby compared the table of values Determine which polynomial function has a greater number of real zeros. What are zeros? First off, that's one of the things you need to do is define what some of the vocab is in the question. So what does zeros really mean to us? Perfect. That makes so much more sense to me. Is okay, I'm looking for x-intercepts. X-intercepts, what else does that mean? What else do I know about that? Y equals 0. Are you with me? How many times, let's look at the picture first. How many times does this thing touch the x-axis? So it has 1. Now, what you're going to probably do is you're going to go quick through this problem. You're going to look at these numbers and you're going to go, Mr. Martin, there's no y that's 0. So this one is bigger. That's exactly what Toby did. He said g of x has the greater number of real zeros because it touches it 1 time. And there's no zeros over here, so that makes sense, right? Does it make sense of what he did? Yes, but he did it wrong. It makes sense of why he got the answer he did, but he wasn't thinking through this, which is what happened to me. I thought they were going to play nice. They're not playing nice. They're not giving you these values. What happens to my y in between -2 and +3? What has to happen if I go from down here to all of a sudden over here? What has to happen when I go to that point? I had to cross the x-axis, didn't I? Now, it crosses it in between -2 and -1, so it's a decimal. It's not a whole number, which is what they only graphed was whole numbers, which makes sense. But does it have an x-intercept? How many does it have? There's 1, and what happens right here? There's another 1, because this thing is a parabola. So how many x-intercepts does this thing have? 2. So which one is actually greater? F of x. That's the type of question that this chapter section is asking. Real thinking questions. Do not go too fast on any of these questions. Yes.
How is it 2?
Yes. So the question was asked. How does this have 2 x-intercepts, but over here it only has 1? These are 2 different functions. One, they gave you a picture of it. One, they gave you a table of it, and you're comparing the 2 back and forth. All right, so what I'm actually going to ask you to do is watch the rest of this video, but I'd rather you try some of these on your own. So try problem 2, and I'll put the answers up. We'll talk through it quickly, but try A, B, C, D, and E on your own, and then come back and watch the video, and I'll talk you through them so that we have the answers to them. So if we look, polynomial function has 1 absolute value and 1 relative. Which one has a greater degree? So I need to know, is this x to the 3rd, 4th, what is it? Well, if I think about this, let's draw a picture. If it has an absolute max, it means it goes up, and that's the highest point it reaches. But it also has a relative max, which means it kind of comes up again, but it doesn't go quite as high as it did the first time, and it goes back down. Well, if I think about that, that would have to be at minimum something to the 4th power. Over here, even if I distribute this out, my x is only going to get to be the 2nd power. So if I was looking at that, this would be the winner, x to the 4th power. All right. So for this one, I look at this guy and I realize it's quadratic. The reason I know that is here's my vertex and it starts repeating. All right, so this problem, I would look at this and know that this is a parabola because I can see that it is mirroring itself. As I was saying, that these are 3 and 3. You got 9 and 9. So even if I drew a quick graph of it, it'd be 0, 1, -1, 3, +1, 3, and I've got that parabola shape going on. So I know this is probably x to the 2nd power. So which one's going to have the greater degree? Well, this has 1 real 0 and 1 it has an imaginary. We also know that imaginaries have to come in pairs, which means I have 1 real. Since I know they come in pairs, I have 1 real. I have to have at least 2 imaginary, which means I have a total of 3 roots. If I have 3 roots, then this thing has to be x to the 3rd power at minimum. So this polynomial is going to have the greater number of degree. Problem C, which function has a degree divisible by 2? If they tell me it's divisible by 2, I know it is a even function. That's basically what they're asking me. Since I know this function only has imaginary solutions, I know imaginary solutions have to come in pairs. Since they come in pairs, I know this guy has to be the even one. If I look at this guy and I start graphing it, negative 2, 2, negative 1, 4, 0, 6, 1, 8, it looks like this guy is some kind of linear function, which is going to be odd. Starts down, ends up, I at least know that it's odd, which is not even. Alright, so for this guy, which one has a greater output as x approaches infinity? That means as x approaches infinity, as this thing is going to the right, which one has a greater output? Greater outputs are going to be positive numbers. So I'm looking at in behavior here. This is an odd function, and my a is less than 0. That means I have a negative x and an odd power. If I have that, I know it starts up and ends down. So as this thing is going to infinity, it's got negative outputs. So I've got negative outputs here. This guy is even and it is positive, so I know that it's probably going to look something like this. But all I care about is as it's going towards this way, it's continuing up, which means it has positive outputs. So this guy is going to have greater outputs. Okay, so this one you've got to definitely be careful on. Part E, because they're saying which one has greater output as x approaches negative infinity. Alright, with this one I have some discrepancy with the book. The book is saying that this guy wins, so I'd actually appreciate if you guys would look at this and see what you think. I asked Ashnak, and she agrees with me that we think this guy, because this thing, so right here, we know that this is even and negative, so as it approaches negative, and I know my end behavior is down, and I know it starts down, ends down. Whereas this guy over here, I know it's got all imaginary roots. I know that it's, I know that this thing has an intercept of 5. 1, 2, 3, 4, 5. So I know that it starts up, somehow gets here, and ends up. So to me, as this thing is approaching negative infinity, the greater output is up here. So I believe this guy wins. I hope I did a good job explaining that. So I know that this is quartic. This means x to the 4th power, and it was all imaginary roots, which means it never crosses the x-axis. So I know it starts up, never goes past, really goes down here. It might dip down here, but it never touches the x-axis. So I know it looks like that, but like I said, as it's going to negative infinity, as this thing is going this way, it's going positive. My outputs are greater when they're up here. I don't understand why the book is saying this. So sometimes that happens. Alright, so this guy right here, these guys disagree. They want to determine which one has an odd degree. So which one is odd? Well, a function that has an absolute maximum. If something has an absolute maximum, it's got to look like this, it's got to look like that, it's got to look something like this, but every time you're noticing, the only way we talked about having absolutes is if it was even. So right here, I know this guy has to be even. By elimination, that means that this has to be the odd function. But if we expand this out, this is the 4th power, there's an x, there's a 2nd, there's a 4th, so if you count how many x's this is x to the 4th, there's another x, so that's 5, 6, 7, 7 plus 4 is, this should be x to 11 if you expand that fully out, so that's an odd power. I hope you see how I counted that. That's 4, there's another one, 5, 6, 7, 7 plus 4 is 11. Alright, so we're going to skip down to problems like this, which are going to be very similar, but it's just going to ask based on other, you can hopefully read through you might want to read through this question. They give you the solution and talk about it, so you might want to read through that. But this one right here, so Isaac and Tina disagree over which function has the greater y-intercept. So again, I need to think about all the things I know about the y-intercept. If I'm on the y-intercept, I know that my x equals 0. So if I think about that over here, this means that my ordered pair is 0, 4. Well, right here, they didn't give me that value. But I do know that my x equals 0. So if I wanted to find my y-intercept, I could plug in a 0 for all my x's and find my y-intercept. So if I do that, I get 2 times the negative 2 times 2 times the negative 3 minus 4. All I did is I plugged in 0 for all those x's. And 2 times 2 is a negative 4. Negative 4 times 2 is a negative 8. Negative 8 times a negative 3 is a positive 24. 24 minus 4 equals 20. This has a greater value, so it looks like Isaac would have been correct. And we know that because Isaac's a boy and boys are always better than girls. So, alright. So again, for these rest of these problem 2, I'd like you in 3, I'd like you to try to do them. So pause the video, give yourself a chance to think through them, and then I'm going to talk all the way through it. So this is going to be a longer video, but that's just because we're going to refer back to it. So, which function has a greater average rate of change for the interval from negative 4 to 4? So average rate of change is kind of what we were supposed to do in 4.5.2. We didn't do too much of it. But average rate of change, so it's from the interval 4 to negative 4. So if I'm talking about interval, that is not an ordered pair. Please make note of that. That is my x starting value to my end starting, or my end value of y. So that, my starting value of x to my end value of x. That means I'm going to look from here to here and average that rate of change. So the way that you do the average rate of change is you pick your ordered pair here, and you pick your ordered pair here, and you find the slope between them. But when I do that, my ordered pair, remember, it's y minus y over x minus x. And we're doing the average, so I'm picking this point and doing the last point and seeing what it is. But when I do that, my point is negative 4, 4, and my point over here is 4, 4. Well, when I do my y's, right away I see that it's 4 minus 4 over, really I don't care what happens in the bottom, it's 4 minus 4, but anyways I end up with a 0 over negative 8. Well, what I realized is that the 0 in the top, this has an average slope of 0. Whereas if I look at this guy, it's just linear. And so 0, 0, 1, 1, 2, 2, the way I remember X and Y chart if I wanted to graph this out. And so I look at that, and just by looking at it, it doesn't change its average rate of slope. The slope is 1 all the way through, and I can look right here and see that it's 1 over 1. So my average slope is 1, so that means g of x has a greater average rate of change. So these are the type of questions. So which one has a greater average rate of change from the interval from negative 1 to 1? So you're going to start here, negative 1, and go to 1. So you're going to use this ordered pair, and you're going to use this ordered pair, which it looks like it's negative 1, 3, and this one is 1, negative 3. And if we do this, it becomes y minus y. Remember, I always try to make it positive if I can, so it becomes 3 minus the negative 3 over, remember if I did this one first, if I did the 3 first, I have to put this first, negative 1 minus 1. And so it looks like it's an average rate of 6 over a negative 2, which is an average of about negative 3, or negative 3 over 1. If I do that, 3, down 3, 1, 2, 3 over 1. That's pretty close. Down 3, 1, 2, 3 over 1. That's actually spot on. Down 3, 1, 2, 3 over 1. Pretty close again. Down 1, 2, 3 over 1. It's spot on. So you can see how that is the good average of that. Now with this guy, I'm going to use from -1. So there's my ordered pair to 1. So there's that ordered pair. So remember, y minus y. Well, it's going to be 1 minus 1 over -1 minus 1, which gives me a 0 over a -2, which is a 0 slope again. So which one is actually a greater average rate of change? So they try to trick you on this question because 0 is actually greater than -3. So this guy actually has a greater average rate of change because it's a negative number versus 0. 0 is going to be a greater number. So those are the type of questions. That's why I said these are very, very tricky, thinking through kind of questions. All right. So like I said, you should try the rest of these guys. And I'm just going to talk through them to give you the answers so you can go through them this weekend and hopefully look at it because we got a test on Monday. And I definitely ask some questions similar to this. So which one has a greater relative minimum? Okay, a relative minimum. If you look right here, this graph has a relative minimum. The reason I know it has a relative minimum is because it kind of dips down. And if I look at that relative minimum, it's somewhere around 2. So it's around 2. It's just underneath it. Alright, so again, I'm going to use a lot of my old stuff. I know cubic function is x to the third. It's odd. My a is positive, so I know this is a positive. It has 3 distinct roots. That means that it touches the x-axis 3 times. So if I draw just a generic picture of that, I know this thing starts down and ends up. So I go like this, I go like this, and I go like that. Now, I don't really care where this happens. If you look at this, where is my relative minimum? Remember, the lowest this graph hits is right here. What kind of number do I automatically know this is going to be? It's going to be a negative because it's happening below the x-axis. Where did this one happen? Above the x-axis. So by default, I don't care where this happens. Even if it's only a -1, I know it's a negative number, and a negative output is always going to be smaller than a positive output. So this has a greater relative minimum. I'm telling you, these guys are awesome. Thinking questions, going over some old stuff. Again, old stuff. The axis of symmetry. Axis of symmetry, if I look, this is my axis of symmetry. And my axis of symmetry is x equals 0. Now with this guy, they didn't give me a picture or the axis of symmetry, but I know that formula. Opposite of b over 2a. Opposite of b is positive 3 over 2 times 1, which gives me a positive 3/2. So if I compare these two numbers, x equals 3/2, which one is greater? Make sure you always look back at that because they can switch it up. They might say less. So be careful on that. 0 is smaller than 3/2, so this guy has a greater axis of symmetry. Again, here's a question that I'd love for you guys to look at and make sure that I'm seeing this correctly. So here's what I think. This guy right here, if we look at this guy, I know that again that it's a parabola because here's my vertex and I've got some mirroring that's happening. Okay, I got the same y. So as soon as I start seeing that, I think that I have a parabola. So my vertex is 0, 1. So this is my vertex, and I know that it's going up. So this vertex is actually my minimum point. But when I come over here, I look at this guy. It's asking me for which one has a greater minimum. But when I look at this guy, it's a quartic function, which means it's x to the 4th. Its a is negative, so I know that it's a negative value here. And 2 pairs of real zeros. That means that this thing starts down, it hits right there, but when it has a multiplicity, it bounces right back down, goes up, and it's got that twice where it hits it and bounces back down. So right here, if I look, the minimum value is negative. I don't care where it is at negative, it's just negative. This guy right here has a minimum that's positive, so I know this guy has a greater minimum value. So Delio is correct. If you read the answer, it talks about that kind of stuff. So there's pictures. Remember, for these guys, you want to draw pictures, you want to know everything, talk about everything that you know for these questions. So last couple, I know this is a very long video, but you have the whole weekend to go over it and make sure. Like I said, this covers a lot of stuff that we've gone over. Alright, so So which one is going to have a greater output for a given input? So they're saying, if I give you x at 1, which one has a greater y? Or if I say x at 3, which one still has a bigger y? So they're not telling you the specific one. They're saying always which one is going to have a greater output. So again, let's draw a picture. I know that this is just x squared. I know that it's a parabola like this. Well, this guy is the same thing, except I know I have shifts. This moves it to the right 2 and up 1. Well, if I look at this, what happens with all of my y values? Just look at this one, right? 0, 0. Well, if I'm at 0 on this one, my output is way up here, so that's a greater value. If I'm at 1 here, my value looks like it's 1. Well, when I'm at 1 here, I'm at like probably 2 here. So this one is always going to have greater values because of that plus 1 is always going to be up just a little bit higher. Because remember, this is my shifts, and this is a vertical shift up, which means it's always going to be up a little bit higher than this guy was. And that's good for these. If you want to go through these B and C and look at the answers versus, you can always come up to me and look at the book and we'll talk about them. So if you want to do that tomorrow in class, let me know. Thanks.